Okay, hello. So in today's lesson, we're going to be just looking at functions. Now, what is a function? A function is a rule that takes us from one set of numbers, which we call the domain, to another set of numbers, which we call the range. And the rule can be anything. It could be times by 2, it could be plus 6, it could be times by 7, divide by 8, doesn't matter. So here I've got here little algebraic rule here, and we've got y equals x plus 2. So if we let our x values be 1, 2, and 3, they would be our domain. That would be the domain, the values for x that were allowed, the values of x. And what would we get out? We get out the range, which is the values of y once we apply our rule. So when x equals 1, 1 plus 2 gives me 3, x equals 2, 2 plus 2 equals 4, x equals 3, 3 plus 2 equals 5. And these are our output values, these are our range. So this is some way of remembering it. You'll have to find the best way you can. The domain is the input, and that's the x values, and there's an in and the end of domain to be input, and the range is the output, the y values. Now notation people don't like, but here we go for functions. All these things are the same. So we've got what we're used to. Y is our output, y equals 3x squared minus 1, so we put our different values of x in and get our values for y. We say here f is a function of x, so here it's good because you can actually write, if you want to put f3, that means we're going to put 3 in for our x squared. And this one, again, some people like to put a little line in there. This just is another way of saying a function of x, and this is our output. Okay, so the domain, the x values are given with the rule and can be anything. So here x is an element of the real numbers, so x can be any real number. X is bigger than 3. X does not equal minus 2, so it can be any number except minus 2. And then to find the values for your range, you then sketch the graph normally to find the sort of possible start of your y values and the end of your y values. So here we go. Here we've got a little question. We've got f of x equals x squared minus 2x plus 3. And see here, we're given the domain, we're told on what values of x we're going to apply our algebraic rule. So we're going to apply our algebraic rule for x between minus 1 and 2. So we know we're going to just draw our graph between minus 1 and 2. So we might as well actually find the endpoints while we're talking about it. So when x equals minus 1, we put minus 1 into here, we'd get y equals 6. So we've got a point there, so that's going to finish there. And when x equals 2, put 2 in here, we get y equals 3. And so that finishes there. So we shouldn't have that little bit there. We'll ignore that little bit there. Okay, so the other thing we need to know, so if we know where we start and finish, we have to know, because this is a quadratic, because this is x squared, where our minimum is. And there's two ways we know how to do that. We can either complete the square, which we've got here, or we can differentiate and set to 0, because that gives us a stationary point, and then we can find the x value at the stationary point. Okay, so let's remember how to complete the square. We complete the square, we put this little bracket here, because this just says x. We have x, where we've got take away 1. That comes from halving the coefficient in front of x. So this is minus 2, half of minus 2 is minus 1 squared. And if we multiplied out this bracket, you should know you'd get x squared minus 2x plus 1. So we did x minus 1 all squared. You'd get x squared minus 2x plus 1. And we can see we want x squared, we want the minus 2x, and then we want 3. So we've got 1 and we want 3, so we need to add another 2. Now the next bit's quite a tricky bit actually, and you want to really make sure you understand it. Now you should know that if you square any number, it's always going to be positive. So this thing here is always going to be positive. So this is always going to make our function of x bigger, or at best 0. So if we want the minimum, we want this to be equal to 0. It's never going to be a negative number. So when does this equal 0? This equals 0 when x equals 1. And when this equals 0, what's our y or our f of x? Our f of x will be 2. So our minimum is at point 1, 2. You might want to go back over that. Just make sure you understand it. We're looking for the point when this equals 0, because it will give us our minimum value. Because once this isn't 0, it's always going to be positive. It's always, because of the square, we're always going to get a bigger number than 2. So we've got it here, and then we look, what's our range for y? What possible values could y have? So y, smallest value y could be is 2, and the biggest value y could be is 6. So our possible values for y are between 2 and 6. Okay, so functions can be 1-to-1 or many-to-1. I just want to note, functions cannot be one-to-many. We must only have one output value. We can't have a choice of output value, so we only want one output value. So they can be 1-to-1 or many-to-1. So what does that mean? Here, hopefully you can see, if I draw a straight line, that when we put an input value of 3, we've just got one output value here. So here we've got just one output value. So that means we've got one input, one output. So when we do that, we can see we've got one input, one output, which means we've got 1-to-1. Now this one is slightly different because we've got an input value here and here and here and here, which will give you the same answer. They all give you the same answer. So we have many ways to get one answer. So here we can see that we can have an input there and an input there, and we get the same answer here. And here we can see here this value of x, this value of x, sorry, this value here and here. So we have different x's which will give you one value or the same value for y, and these are called many-to-one functions. Many-to-one functions. So for different values of x, you can still get one answer for y. So it's important to understand what a one-to-one function is and a many-to-one function. Okay, we'll leave that there for now. There'll be more work on functions. I hope that's helpful.